Imagine a map of the universe, and there's a blank spot, not hard to see, not a little empty, a clean, unnatural gap, like someone erased a piece of reality and forgot to fill it back in. Now, here's the part that should make you uncomfortable. Space is supposed to be empty. That's normal. But on the largest scales, the universe isn't random empty. It has structure, patterns, a cosmic web, threads and knots of galaxies, like city lights connected by highways. So when astronomers draw these maps, they expect some dark pockets. They do not expect a pocket so empty. It looks like a hole punched through the cosmic web. And yet, that's exactly what they found. This is not a black hole. It's worse, because it's nothing. No swirling disk, no violent jets, no obvious monster you can point at and say, "That's the culprit." Just absence. The first time you hear about it, your brain tries to rescue the universe. You start offering excuses. Maybe the telescope missed it. Maybe there's dust in the way. Maybe the galaxies are there, but they're hiding. That's what makes this story so addictive. Scientists tried those explanations first, and the hole kept surviving the tests. Because the shock isn't that there's a void, the shock is how big it is. We're talking about a region so vast that light needs hundreds of millions of years to cross it. Yet, compared to the space around it, it's almost empty of galaxies. Not a little underdense, not less crowded, almost nothing. And if your instinct is to say, okay, so what? Empty space is everywhere. Here's the twist. This kind of emptiness isn't supposed to be this extreme. If the universe grew from tiny ripples after the Big Bang, ripples that gravity pulled into today's galaxies, then even the emptiest regions should still have plenty of islands of light. This one doesn't. Which raises a question that feels almost illegal to ask. What if our maps are missing something fundamental? In this video, we're going to do 3 things in order, no hand-waving. First, we'll follow the evidence, how astronomers even noticed a missing patch in the first place, and how you confirm it's not a mistake. Second, we'll scale it properly, because your brain will underestimate it unless we force it to see the size. When you understand the scale, you'll understand why scientists couldn't just shrug and move on. And third, we'll talk about the explanations, the boring ones, the plausible ones, and the ones that get weird. Because once you start asking why a void this extreme exists, you're really asking how the universe builds its structure at all. It's called the Boötes Void, and by the end of this video, you'll understand why this isn't just a curiosity on an astronomy chart, it's a stress test for our picture of reality. Because if a hole this large can exist, what else is out there that we haven't noticed yet?
What else is out there?
So, how do you even find a hole in the universe? It's not like someone pointed a telescope at one spot and saw a sign that said, empty. This was discovered the boring way first, which is exactly why it's disturbing. Astronomers started doing something that sounds simple. They began making large-scale maps of where galaxies are. Not just a few pretty images, real surveys, real counts. Imagine you're flying over Earth at night. You can't see people individually, but you can see city lights. You can see where the dense clusters are, where the highways connect them, and where the dark countryside begins. Now imagine you're doing that for the entire universe. That's basically what galaxy surveys are, a way to count city lights across space and build a 3D map of where matter has gathered. And when scientists started plotting those maps, they noticed something strange in one region of the sky. It wasn't a tiny gap. It wasn't a normal, less crowded patch. It was a region where the numbers didn't behave. Because normally, if you move your gaze across space, density changes gradually. You get thick areas, thin areas, and transitions between them. But this was different. This was like driving through a world that has towns, then suburbs, then farms, and then suddenly, for an impossibly long time, nothing at all. No lights, no towns, just black. At first, you do what any careful scientist would do. You assume it's your fault. Maybe the telescope sensitivity drops in that direction. Maybe the survey missed faint galaxies. Maybe there's some observational bias, some reason the data is lying. So they checked. They compared observations. They expanded the search. They looked for galaxies at different brightness levels and different distances. And still, that region stayed weirdly empty. Eventually, it got a name, the Boötes Void. And even the name itself is revealing. It's not named after what it is. It's not a thing you can point at. It's a volume, a three-dimensional region of space, which means you don't discover it by seeing it directly. You discover it by realizing what's missing. Think about how humans detect absence in everyday life. You walk into a crowded room and you don't notice most faces. But you notice an empty chair at the center like it's glowing. That's what happened here on a cosmic scale. The void wasn't screaming, "I'm here." It was whispering, "Look at what isn't." Now here's where the story gets even more unsettling. This wasn't found by a single person having a weird night at the telescope. It showed up in the patterns, when researchers counted galaxies and compared regions of sky. And once it had a name, it became something other astronomers could test. They could aim deeper surveys at it. They could check whether faint galaxies were hiding. They could look for any evidence that the whole was an illusion. And the more they checked, the more it started to look like the universe really had carved out a region with far fewer galaxies than expected. Not empty like vacuum, empty like, why is this missing? And that's the key point. The Boötes Void is not famous because it's the only void. The universe is full of voids. That's normal. The Boötes Void is famous because it's a void that feels too big, too clean, and too extreme to ignore. And we haven't even talked about the scale yet. Because once you understand how large this region is, your brain will stop treating it like a curiosity and start treating it like a problem. All right, now we do the part your brain is going to resist. Because the moment I tell you the size, your mind will try to shrink it into something familiar. It will try to imagine a big, empty space, like a gap between stars, or a dark patch between galaxies. That's not what this is. This is emptiness on a scale that makes normal emptiness look like a pinhole. Let's build the scale the only way that works, step by step. Start with the Milky Way. The Milky Way is so large that if you could travel at the speed of light, 300,000 kilometers every second, it would still take about 100,000 years to cross our galaxy from edge to edge. That already sounds ridiculous, right? Now zoom out. The Milky Way isn't alone. It sits in a small neighborhood called the local group. Dozens of galaxies bound together by gravity, including Andromeda. If you widen your view to include the local group, you're now dealing with distances measured in millions of light years. Millions. Now zoom out again. Beyond the local group, galaxies gather into clusters, and clusters link into superclusters, giant structures that look like knots connected by filaments, like a spiderweb made of galaxies. At this scale, you stop thinking in galaxies and start thinking in regions. Because the universe is not a scatter of isolated islands. It's an architecture. And voids are part of that architecture. Normally, a void is like a bubble in foam, an area with fewer galaxies, surrounded by denser walls and filaments. But the Boötes Void? The Boötes Void is a bubble that looks wrong. Depending on how you measure it, it's on the order of hundreds of millions of light years across. Let that land. Hundreds of millions. If the Milky Way is one city, this void is an entire continent where the lights are out. And here's the part that makes it feel even stranger. It's not just that it's huge, it's that it's unusually empty relative to its size. Because people hear void and assume nothing at all. Technically, that's not true. Even in a void, you can still find some galaxies, just far fewer than average. And yes, astronomers have found a few galaxies inside the Boötes Void. But they're like lonely boats on a black ocean, so sparse that the first reaction isn't, "Oh, it's a normal void." The reaction is, how did the universe allow this big a gap to stay a gap? To understand why that's unsettling, think about a crowd. If you pack people into a stadium, you expect some empty seats. But you don't expect an entire section, thousands of seats, perfectly empty, with everyone else clustered around the edges. That would feel intentional. And the Boötes Void feels like that in the cosmic map. Now here's another way to think about scale that hits harder. If you tried to cross this void at the speed of light, you would not make it in a lifetime. You would not make it in 1,000 lifetimes. You would not make it in the entire history of human civilization. You'd be traveling for hundreds of millions of years. Civilizations could rise and fall, species could evolve and disappear, and you'd still be in the void. That's why this isn't just an interesting fact. A region that big isn't supposed to be special, because on truly huge scales, the universe is supposed to smooth out. The larger the region you average over, the closer it should get to normal. That's the intuition behind modern cosmology. When you zoom out far enough, the universe becomes statistically uniform. Not perfectly uniform, but not wildly extreme. And yet, here is a region so large that it should average out. And it doesn't. It stays unusually empty. Which leads to the big, uncomfortable thought. Maybe our expectations about how structure forms, how galaxies clump, how voids carve out, are incomplete. Or maybe the Boötes Void is a rare but real outcome of the early universe, one of those cosmic dice rolls that came up strange. Either way, once you understand the scale, you can't dismiss it as a fluke. Because it's not a hole in a wall, it's a hole in the blueprint. And now we have to ask the next question. Why shouldn't something like this exist? Why does it feel like a glitch in the universe? Here's the part most videos skip, because it sounds technical. But we're going to do it the right way, simple and sharp, because once you get this, the Boötes Void stops being a weird fact and becomes a real problem. The universe is not a random spray of galaxies. If it were, then a huge, empty patch wouldn't be that shocking. It would just be bad luck. But that's not what we see. When astronomers map the universe, they see something closer to biology than chaos. A living structure. Galaxies form clusters. Clusters connect into filaments. Filaments create walls. And between these walls are bubbles, voids, like the empty pockets in foam. This pattern is called the cosmic web, and it's one of the strongest pieces of evidence that the universe grew from tiny ripples. Here's the idea in plain words. In the early universe, matter wasn't perfectly smooth. It had tiny density differences, microscopic, more here, less there. Gravity took those tiny differences and amplified them. Where there was a little extra matter, gravity pulled harder, collecting more matter, growing into galaxies and clusters. Where there was a little less matter, gravity pulled less, so those regions fell behind, expanding into voids. So voids make sense. They're not mistakes. They're part of the mechanism. But, and this is the key, voids have limits. Because gravity is relentless. Even in a region that starts slightly underdense, matter still exists. And over billions of years, things drift, merge, interact. You expect emptiness to be temporary or incomplete, not clean and extreme. So when cosmologists see a void, they don't just ask, is it empty? They ask, how underdense is it compared to normal? Because a little empty is ordinary, shockingly empty is rare. And the Boötes Void falls into the second category. It's not just a void, it's a void that feels too large and too underpopulated to fit comfortably inside the usual cosmic web story. Now, to be fair, the universe is big, and big systems produce rare events. You can flip a coin 1,000 times, and eventually you'll get a run of 10 heads. It doesn't break reality, it's just probability. So yes, in principle, an extreme void could happen. But here's why this one bothers people. In modern cosmology, when you simulate the universe, starting with early ripples and letting gravity do its thing, you do get voids. You get big ones. You get impressive emptiness. But voids on the scale of the Boötes Void sit right on the edge of what feels plausible without making you raise your eyebrows. Because the larger the region you consider, the more average it should become. This is the part that matters. If you zoom in on a small patch of the universe, sure, you can find strange things. But if you zoom out to a region hundreds of millions of light years across, your expectation is that extremes should fade. The universe should stop being dramatic and start being statistical. And yet here is a region so large that it should have smoothed out. And it didn't. That's why people describe it like a missing piece. Not because it's literally a hole cut out of space, but because it feels like something that should have been filled in by the universe's normal process of structure formation. Like a bubble that grew too large and never popped. Now, there's another layer to why it feels wrong. Voids aren't isolated. They're shaped by what surrounds them. If you have a big void, you usually expect strong, rich structures around it. Walls and filaments where matter got pushed as the void expanded. And yes, the universe around Boötes does have structure, but the sheer scale still makes you pause. Because if a void can become that big, it hints that the early ripples weren't just small random differences. It hints that some regions may have started extremely underdense. And if that's true, it pushes on the assumptions we use to interpret other things, like the cosmic microwave background, the distribution of dark matter, and the way galaxies should be arranged. So the Boötes Void sits in a dangerous place. It's not a single impossible fact you can easily disprove. It's a statistical embarrassment. A region that might be possible, but makes you wonder if we've underestimated how weird the universe can be. And once you reach that point, the next question becomes unavoidable. Okay, if it shouldn't exist so cleanly, then what could explain it? In Part 2, we're going to test the explanations one by one, the safe ones, the plausible ones, and the ones that get unsettling. Because the deeper you go, the more it feels like this hole isn't just empty space. It's a clue.